Hello fellow math, I am Dr. Vilva and meet my friend Brinda.
Hi, you just found me in UK, that is unknown to known channel. Here, numbers stop being scary and start to say story. Let us involve, learn and win.
In this video, we are going to discuss the 3-mark questions from chapter 1. We have already covered the core concepts of this chapter as well as the 1 and 2-mark questions in our previous videos. You can find all of those links in the description below. You can expect a 3-mark question from this chapter in your exam. Let us look at our very first question. It is a direct one. We are given 3 expressions P, Q and R, which is expressed in terms of 2 distinct prime numbers X and Y. Our mission is to find their HCF and LCM, which is the direct question. Also, they asked us to cross-check if the given relation, that is HCF of PQR times LCM of PQR is equal to P times Q times R or not. We will see the solution. If you have watched our previous videos, definitely you can solve this question by yourself in no minutes. Anyhow, we will see the solution now. P is given as x square y cube, Q is x y power 4, R is x power 5 y square. First, we will find the HCF. Remember the golden rule for HCF. We look for the common prime factors with the lowest or minimum power. Let us look at x first. We have x square, x, which is x power 1 and x power 5. What is the smallest power here? It is just x or x power 1. Now, let us look at y. We have y cube, y power 4 and y square. The lowest power here is y square. Multiply them together. Bingo! Our HCF is x y square. Next, we find the LCM. For LCM, we do the exact opposite. We take the highest or maximum power of every prime factors involved. Let us check x again. Between x square, x and x power 5, the highest power is x power 5. For y, between y cube, y power 4 and y square, the highest power is y power 4. So, our LCM is simply x power 5 times y power 4. Now, for the further part of the question, let us verify if HCF times LCM equals the product of the 3 numbers P, Q, R. A lot of students trip up here assuming it always works. So let us test it out. Are you ready with me? Let us find LHS part first. HCF times LCM, which is x y square times x power 5 into y power 4. When we multiply these terms, we add the exponents. So, x powers are 1 and 5. Therefore, 1 plus 5 is 6 and 2 plus 4, which is 6 again for y. That gives us HCF times LCM as x power 6 times y power 6. Let us find the product of three numbers P, Q, R, which is our RHS part. So, P times Q times R equal to x square y cube times x y raised to 4 times x power 5 y square. Again, let us add the powers. For x, 2 plus 1 plus 5, which is 8. For y, 3 plus 4 plus 2 is 9. That gives us x power 8, y power 9. Look at that. LHS part is x power 6 times y power 6, whereas RHS part is x power 8, y power 9. They are not equal. Therefore, HCF of PQR times LCM of PQR is not equal to P times Q times R. This is a fantastic remember of a crucial rule in math. The property HCF times LCM is equal to product of the numbers only works for two numbers. It does not generally apply to three or more numbers. Next question is a classic type of question that tests how well you truly understand prime versus composite numbers. We have two statements and we need to determine if they are true or false. And most importantly, we should justify our answers. Let us break them down one by one using a really smart math shortcut so you don't waste time doing heavy multiplications in your exams. Let us look at the first one is 2 times, 3 times, 5 times 7 plus 7 a composite number. Now, you could multiply 2 times, 3 times, 5 times 7 and add the answer with 7 and then try to factor the result. But there is a much faster way. Remember, a composite number is any number that has factors other than 1 and itself. Notice that we have two terms here and 7 is common to both terms. Let us take 7 out as a common factor. So, 7 times 2 times 3 times 5 plus 1. Here, already we got one of the prime factors, 7. If you multiply 2 times 3 times 5 plus 1, we will get another number. If you want, you can simplify or directly we can conclude at this stage. Anyhow, I have simplified it. 2 times 3 times 5 is 30. 30 plus 1 is 31. So, this expression can be written as 7 times 31. Because this number can be expressed as a product of two prime numbers, that is 7 and 31, it clearly has factors other than 1 and itself. Therefore, it is absolutely a composite number. So, statement 1 is true. Now, let us look at the second one is 2 times, 3 times, 5 times 7 plus 1, a composite number. If you try the factorizing trick here, it won't work because there is no common factor between the first part and the number 1. So, for this one, let us just do the quick math. First, let us multiply the numbers 2 times, 5 times, 3 times, 7 times, 21 times 10 gives us 210. We add the 1, therefore 211. Now, we need to check if 211 is prime or composite. The number ends with 1. It means it is not an even number. It's not divisible by 3 because 2 plus 1 plus 1 is 4. 4 is not divisible by 3. Last number is not 5 or 0. Therefore, it is not divisible by 5. I have used a trick here that I will share with you shortly. Now, quickly check whether it is divisible by other prime numbers 7, 11 and 13. None of them divide 211 perfectly. Therefore, we will conclude that 211 is a prime number because it has only two factors, 1 and 211. Therefore, 211 cannot be a composite number. Statement 2 is false. The trick I have used here is to check whether 211 is a prime number. We don't need to divide it by every number less than 211. Instead, we use a useful rule. We only test prime numbers whose squares are less than or equal to 211. Why? Because if 211 has a factor larger than its square root, the matching factor would have to be smaller than the square root. So, checking up to the square root is enough. I hope it makes sense. The square root of 211 is approximately 14.5. We need to check the prime numbers up to 14 or 15. So, I have checked for 2, 3, 5, 7, 11 and 13. 211 is not divisible by these prime numbers. Since none of these prime numbers divide 211 exactly, I have concluded 211 has no factors other than 1 and itself. Therefore, 211 is a prime number. If this quick breakdown made your homework or exam preparation a little easier, don't forget to hit that like button and subscribe to the channel. Drop your comment below if you have any questions. Coming back to our problem, the first statement is true because we could easily factor out a 7, making it composite. The second statement is false because the total adds up to 211, which is a prime number. Moving on to our next question. This one looks a bit abstract because it uses variables instead of numbers. But don't let that scare you. It uses the exact same logic we just mastered. We have three distinct primes P, Q and R. We need to check if the expression P, Q, R plus Q is composite. Just like before, let us look at the two terms in our expression. Do you see a common factor? Yes, absolutely. Q is present in both terms. Let us take Q out as a common factor. Q times PR plus 1. We know Q is a prime number, so Q is greater than 1. Since P and R are distinct prime numbers, so the term PR plus 1 is also an integer greater than 1. Because the entire expression can be written as a product of two integers, both greater than 1, the resulting number must have factors other than 1 and itself. Therefore, PQR plus Q is always a composite number. Now, let us move on to the second part of the question. What happens if we add 1 instead of a common factor Q? The question asks us to find examples of 3 distinct primes P, Q and R for 2 different scenarios. We will do it by trial and error method. First scenario, PQR plus 1 should be a composite number. Let us choose 3 small distinct primes. I have tried with few combinations of prime numbers and I am sharing the final answer with you. You can try with some other numbers also. Here you will be having multiple answers. My solution is, if P is 3, Q is 5 and R is 7, calculate PQR plus 1, that is 3 times 5 times 7, which is 105 plus 1. Final answer is 106. Since 106 ends in an even number, it is easily divisible by 2. Since it has factors other than 1 and itself, 106 is a composite number. Let us try a different set of distinct primes. When P is 2, Q is 3 and R is 5, let us plug them into our expression. We will get 2 times 3 times 5, which is 30 plus 1. 31 is a prime number. Our next question is to prove 1 by square root 5 is irrational. Now, proving something is irrational directly can be tricky. So, instead, we are going to use a brilliant mathematical strategy called proof by contradiction. To start a proof by contradiction, we begin by assuming the exact opposite of what we want to prove. So, I am going to take 1 by square root 5 is a rational number. By definition, any rational number can be written as a fraction. So, I am taking it as R by 5, where R and S are integers and S is not 0. I am going to do simple mathematical simplification here. Just cross multiply the terms. We are going to get square root of 5 is equal to S by R. In this case, R should not be 0. Now, R and S can be a coprime. If not, it can be reduced to coprime by dividing it with the common factor. If it is simplified, it is equal to A by B, which is coprime. So, finally, square root of 5 is A by B. Does this look familiar? It is the exact same situation we discussed to prove square root 2 is irrational in our previous video. Now, the direct proof for this is something we have already covered in detail in a previous video. I have placed the link to that step-by-step solution right down in the description below. So, definitely check that out if you need a quick refresher. Our next question also asks us to prove square root 2 is an irrational number. Similarly, other questions on your previous exams papers are asking to prove that square root 3 is irrational or square root 5 is irrational. These all follow that very same logical pattern. Next, let us look at a slightly different type of problem. You might see a question like, prove that 5 square root 3 plus 2 by 3 is an irrational number given square root 3 is irrational. We have already discussed how to handle the sum and quotient of rational and irrational numbers in our previous video. So again, please check the description for that link. Our next question is also the similar one. Prove that 4 square root 2 plus 5 by 3 is an irrational number. Alright everyone, let us quickly summarize the exam blueprint for chapter 1. From this chapter, you can expect 1 or 2 1-mark questions which is MCQ type, that is multiple choice question. Then you can expect 1 2-mark question, 1 3-mark question. We have successfully covered and discussed all of those important questions in our previous videos. If you missed any of them, make sure to go back and watch the playlist so your foundation is rock solid. It's time to level up. In our next video, we are going to start chapter 2. We will break down the concepts, solve the textbook problems and look at the most expected exam questions just like we did for chapter 1. Let us involve, learn and win together. Thank you. Bye-bye.